Next up, we have Reijin Zhang, Lead Marketing Analytics at DirecTV. Reijin will tell you about ML in marketing retention. I'm excited to learn more. Welcome, Reijin. We'll take a 20-minute break after this talk, and if you haven't already, please make sure to send some meeting invites via the event app and meet some other attendees for a 15-minute conversation. Okay, let's proceed with the next chat, shall we? We're just going to take one moment. I'll just, you guys have any questions for me? I don't know. Yeah, after this we'll have a little coffee break. Plenty of delicious stuff coming. Also, just worth a reminder that that's where our meeting corner is, over by the wooden paneling. Hi, Reijin.
Hi. Sorry about that. Hi, everyone. Good morning. My name is Reijin. I'm a lead marketing analyst at DirecTV. Today, I'm going to talk about machine learning in marketing retention. I will mainly focus on how we can use machine learning prediction output to do the optimization in the marketing retention. So when people talk about marketing retention, the first question you might ask, what can we do to keep more customers to reduce the churn rate? So in our company, if a customer wants to disconnect a TV service, they need to give us a call, and then we have a customer representative to try different strategies to keep the customers. So what can we do in the call? Surprisingly, we design different offer values to give the customer. The offer, I mean the discounts. The offer value should be always lower than the margin. And we offer different, the offer values start from 0, 5, 10, and all the way up to $90 discounts with $5 increase in each offer level. And for example, if we know we can earn $20 from a customer, then we can see we can offer them 0, which means no offer, $5, $10, or $15 discount. If you are the agent, which offer will you give to the customers? Someone might say, let's give them $15 because the more discounts that we give, the higher chance that we can keep the customer. But don't forget, the company also wants to save the money. Yeah, so if we think we can spend less money and achieve the same marketing retention rate, that would be the ideal. So in this case, we can introduce machine learning in the game between the customers and the company. So how we can use the machine learning models to help us make a better decision? Here we design two types of models. It's a PDIS model and treatment model. PDIS model means which we can predict the probability that the customer will have a pending disconnection, and treatment model is to predict what's the probability that the customer will accept the offer if we give them offer value X. And we have our historical data, which includes the callers' information, the offer they got in the history, and their pending disconnection and treatment result. And for each type of offer, and we can associate the offer with two models. We can still use the example I mentioned in the previous page. That customer has $20 margin, and he is eligible for 4 offers. And each offer can be associated with PDIS and treatment model. So in this case, there will be 8 models for this customer, and there will be 8 model predictions. Right now, so besides these 2 models, the PDIS and treatment, we also designed the third model. It's called call probability, because we only can give the discounts to the customer who give us a call. So the call probability model will be used to predict the probability that the customer will give us a call. In the bottom, there's a flow chart to show the whole process, machine learning process in a high level. We have the callers' information, like their tenure, whether they set up payment or not, their margin, what kind of a TV package plan they purchased, and whether they have a call before, how much credit or discount they already got. And then we can do some data pre-processing work, like we need to check the missing values, outliers, and do the data transformation, and apply the one-hot encoding on the categorical data. And then we split the data into training and testing side, try different machine learning algorithms, and use the grid search to fine-tune the parameter. And finally, we need to validate our model using the AUC ROC score. And also, we also calculate the mean squared error here. How do we calculate mean squared error? It's because we have the prediction value for each customer, and we can rank the prediction value from the highest to the lowest, and we can split the whole population into, let's say, 100 groups. And in each group, we can calculate the mean of the predicted value and the mean of the actual value. And so we can compare the differences between two means, and then we will have our mean squared error for each model. So once we pick the best model, we use ML flow to log the model information, and in each month, we need to collect the most recent historical data to update our model. And in this case, in order to know whether our model is improved or not, we can do some QA process. You have your new data. You can train the new data. You can fit the new data in both your old model and see which one can make a better prediction. So in this case, we can know whether our new model can perform well or not. Now, we already have 3 models here, the PDs, treatment, and call probability. We can still come back to our first question, how we can use machine learning models to help us make a better decision. The company wants to earn money, so they need to know if we give you offer, let's say value X, and how much margin we can earn from each customer. So we come up with a formula to calculate the new margin for each customer. That is equal to their original, their original margin minus the money we will lose if they disconnect, and also minus the money we spend if they accept the offer. Someone may ask, why do you deduct 2 costs here? The customer either accept the offer or they just churn. That is because when we will have the call probability here. Not everyone will call. So if they call, and then we assign the cost equally to everyone. I put one example here. If we only have 5 customers, only 2 of them give us a call. And the one customer, he accepted the offer, $5 discount. Even though in reality, we just gave $5 to one person, but when we calculate the margin, we just equally assign $1 to each person. It means we spend $1 on 5 people. And similarly, if another person rejects the offer, the $5 discount, we also equally split the loss and equally assign to each person. So in this way, we calculate a new margin for each customer. So now we have a new margin here. You might say, okay, let's give the offer which can generate the maximum margin so we can earn more money. But think about that. Some companies, they have their budget limit. So if you only have limited budget, how do you spend money on each customers? You can give some customer more money, you can give some customer less money. So there's another example we can think about how we can do the offer assignment. There's still 5 customers. Let's say 3 of them, they are low margin customers, and 2 of them, they are high margin customers. And you have budget is $25. Do you give everyone $5, or you just spend all money on those 3 low margin customers? In this case, you can save more people because your churn rate might be the 40%, but those 3 people are low margin customers. Or you can spend all money to those 2 high margin customers. In this case, you can earn more profit, but you might lose other 3 people, and your churn rate will be 60%. So, or you can do something else. So now the question becomes how we can balance the margin, the churn rate, and the budget you have. So it's a balanced question. And then we need to think about what's your business goal. it depends. So if your business goal is to say, we want to minimize the pending disconnection, and we have the limited budget money we can spend. So we can put one table here to list all offer increase options we can have. We can still use the customer I mentioned earlier as example. That customer is eligible for offers 0, 5, 10, and 15. And in this table, you can see we list all offer increase options. You can see let's go from the lower value, from 0, and if we increase offer to 5, what's going to change in the PDS rate, and what's going to change in our estimated money spent. And then we can calculate the ratio of the PDS rate change versus the money spent change. What does this ratio mean? It means if you spend same money, which offer increase can reduce more pending disconnect rate. So then you want to pick that one because that one can give you more churn rate reduction. And based on that ratio, we can rank each offer increase path from 1 all the way down. And similarly, if let's say we just want to maximize the margin, but we also want to limit, we can give a rate and see how much churn rate we want to restrict. Then you can calculate, it's similar, we list all the offer increase paths, and we can see what's going to change in their margin and what's going to change in their PDS rate. And the same thing, we can calculate the ratio. The ratio means in each 1 unit of pending disconnection rate reduction, how much margin, because we will lose margin in this case because you spend more money, but we want to have less margin reduction. So that, in this case, we want the ratio to be lower, as low as possible, and then we can also rank each line with their ratio. And also, you can also come up with your own business goal. You can see you can maximize margin and restrict the money spent. You can list another table there. Due to the time limit, I will only show 2 examples here to give you an idea how we calculate their rank and based on ratio. So right now we have the ratio is only the customer level. It's only for each customer. But if you have, you have a whole population, how do you assign your budget to each customers? Here's our steps. So in step 1, we start from the lowest offer values. Everyone get no offers, and then we list the next best offer for them. So you can see the example here. The customer number 1 is, we say, okay, the best offer pass for this customer is increased from no offer to $10, and the second one is from 0 to 15 and all the way down. And in step 2, based on their ratio we already calculated in the previous page, we can rank them in the whole population. And then in step 3, we can start approving and assign new offer to them. But in the meantime, in the step 3, we also need to sum up the restriction. Once you assign new offer, what's the money you spend? And we need to make sure that spend is still within your restriction limit. And once you are beyond your restriction limit, you stop assigning new offers, and other people will keep their original offers. What if in step 3, once everyone get their new offer, you still have more money to spend? You can come back to step 1. So in step 1, in this case, the new offer will be the start point, and you start finding the next best offer values for that customer, and repeat the step 2, step 3 again, and until you reach your restriction limit. So in this case, we do all the offer assignment, optimization process. But do you think it's already done? I will put a question mark here. In this project, we can still explore a lot of things and think more. It doesn't work. Yeah, we need to explore more and think more. We did a very interesting A/B test. You will see why it's interesting. So in this A/B test, we call it like LiDAR. So in our population, we randomly split customer into group A and group B. And in the group A, we just let the customer representative to show the offer value generated from the optimization process. And in group B, we also let the agent to give the customer the offer value generated from the optimization process. But in this case, we changed our strategy. We let agent to start from the offer X minus 10 and gradually increase offer value to X minus 5 and all the way to X. We call it LiDAR. It's because we want to try to show them lower value first. If the customer is unhappy, let's say, okay, we can increase $5 more to you. And then if the customer is still not unhappy, you can say, okay, we give you X. Then that's the maximum we can give. The interesting fact is that we found the churn rate in group A is higher than churn rate in group B. If you think from the customer perspective, you ask agent for a discount. They only give you offer value X. And you want to ask more. They said, no, that's the only thing we can give to you. You are not happy, you just go. But in group B, you think, okay, I already asked more discounts and I'm satisfied. I will keep using your TV service. So I think that's very interesting. And so our team, we discussed about this business problem, and we decided to build a new model. It's for the future, but so this model will be used to predict which kind of customer will be more sensitive to the discount amount. If they are more sensitive, we can apply the LiDAR strategy to them. And if they're not sensitive, we can use the offer value generated from the optimization process. Yeah, so I think that's everything from my today's presentation. I will leave some time for Q&A. Oh.